Alright guys, today we're going to look at some graphs, and these graphs are going to be used to represent real world relationships between any two kind of quantities. So we'll look at this first example. Terrence works at as a flyer mailer for a coffee shop. He sends coupons to valued customers of Second Cup coffee restaurants in Hamilton, Ontario. The graph below represents the number of flyers Terrence has to send versus time in minutes. So what we see here is he starts off with 240 flyers. He gets rid of some, and then there's a little bit of a plateau. And then he gets rid of some more, and jumps back up, and it comes all the way back down until he's got nothing left. Alright? So now we're going to answer some questions from the graph. How many flyers per minute is Terrence stuffing for the first 40 minutes? Alright? So if we're going to answer this question, what we need to do is we need to find the slope of that first piece of the graph. Okay? So, find the slope of this piece of the graph. So rise over run. The rise goes from 240 to 160. So that's 80. The run, well, of course, it's over 40 minutes, right? So it's 80 over 40. So it's just 2. So Terrence is stuffing 2 flyers per minute. Okay? So that's what Terrence is stuffing, is 2 flyers per minute. Alright? Describe what could be happening between 40 and 50 minutes. What could be happening between 40 and 50 minutes on the graph? Taking a break. Could be taking a break. He could be taking a break. Okay? Describe what could be happening at 80 minutes. So what could be happening in 80 minutes? 80 minutes is right here. So what could be happening? He got some more flyers to stuff. Yep. He got some more flyers to stuff. Okay? Now, draw a graph to represent the following situation. Wanda picks up Nancy from the mall, and they go back to Wanda's house to grab Wanda's rollerblades. The two ride to Dairy Queen for a break, and then blade back to Wanda's house. So, here's the deal. Wanda picks up Nancy from the mall. So, assumingly, she's picking her up in a car. So that means the slope has to be pretty steep for this part. So say maybe she goes like that. She waits briefly for Nancy, and then they go back to Wanda's house. So at about the same speed. Now, they're maybe going to stay there for a moment. Maybe it's instant. Maybe they just pick up the rollerblades right away and go. So then they're going to ride to Dairy Queen. So the slope here needs to be less steep. So maybe it needs to be something like this. Then they go for a break. And then they should go home. So something like that would be a reasonable graph for this situation. Okay? So like I said, if she's picking her up, we can assume she's picking her up in a vehicle. So the slope should be relatively steep for the first part of the graph, going to and coming back from picking her up. Then when they're actually rollerblading, the slope obviously has to be a lot less steep. And there needs to be a plateau here because they are going to Dairy Queen for a break. How long of a break doesn't specify, but they are going for one. And ultimately they go back to her house, so it needs to come back down to the X or the horizontal axis. Any questions about that? Okay, a graph below illustrates the total distance traveled by a triathlete that bikes, runs, and swims versus time. At what speed was the athlete biking, running, and swimming? Okay, so biking, running, swimming. Obviously, biking would be quicker than running, and running would be quicker than swimming. So for the biking part, he goes 7 kilometers in 20 minutes. So now we might want to change that a little bit, because kilometers per minute, that's kind of silly. But we could say 7 kilometers. Now 20 minutes would be, if we take 20 and divide it by 60, now that's hours. So if we take 7 and divide it by 20 over 60, you could do that on a calculator if you chose to. You'd probably type it in as 7 divided by 20 divided by 60. That'd give you 21 kilometers an hour. Okay, for biking. Oh, doesn't want to give me, that's odd. Oh well. Alright, let's try that one again. Running. Now we need to find the slope here. For running, we go from 7 up to 11, so that's actually going to be an increase of 4 kilometers here. Over 30 to 80 would be 50 minutes. Over 50 minutes. So if we take that and translate it here, that would be 4 over 50 over 60, so almost an hour. So what would that be? Well, that would actually be 4.8 kilometers an hour. That would be 4.8 kilometers an hour. We can see that it's significantly less. Okay? And finally, we can do the swimming piece. The swimming piece would be, if we take a look at this, we're going from here up to here. So that's an increase of 3 kilometers over 1, 2, 3, 4, 5, 6, 7, 8. So that's 80 minutes. So that's 3 over 80 over 60, which would give us 180 divided by 80, which would be like 90 divided by 40, 9 divided by 4, which would be 2.25 kilometers an hour. So like we suspected, the speed biking was greater than the speed running. Speed running was greater than the speed swimming. Now what we can do is we can take a look at part B, explain what could be happening between 20 and 30 minutes into the race. So what could be happening between 20 and 30 minutes into the race? Well, it could be a break, but what else also is happening? They're transitioning from what? Yeah, so he's probably getting off his bike and getting ready to run, right? More specifically than just taking a break, he's getting off his bike. Because in a race, you don't really take a break. So getting off his bike and getting ready to run.